Hello, and this is 01 Knapsack Dynamic Programming. And for our example, we have four items here, which its corresponding weight and value. For our first item, we have a weight of 1 and a value of 1. For our second item, we have a weight of 3 and a value of 4. And for our third item, we have a weight of 4 but a value of 5. And for our last item, we have a weight of 5 and a value of 7. And for this example, we have our knapsack, which is a total weight of 7. So we made a table with total columns of 7 plus 1 for the 0. And for our first column, which is our zero total weight, you will just be imagining that if we have a 0 kilogram knapsack, and what items are we can be able to put inside there. Since it has a 0 total weight, we can't put anything, therefore everything will be 0 here, because we don't have an item that has 0 weight and that has any value. And for here, our first item, it has 1 kilogram. So if we can put our first item inside the knapsack, which has 1 kilogram, we will be having one value. Therefore, we will be having one value here. And for here as well, since we only have one item to put inside the knapsack, everything in the other columns will also be 1, since that's the maximum that we can have. And in the second row, for our total weight of 1, we can put the second item here yet, because the second item's total weight is 3, so we can put it inside the knapsack, which has a total weight of 1. Therefore, we can only have put the first one here, so we'll be putting that 1 here as well, and which goes with the second column as well, which has a total weight of 2. Therefore, we can only put the first item here. And for the third column, we have a total weight of 3. We can put the second item here, and since the second item is higher, we can do the equation, which is to find the maximum maximum value that we can put inside the knapsack with a total weight of 3. Since the item here is 3 and the value has a value of 4, which is way better than the other ones, we can put 4 here, plus the total weight of in the table, 3 3 columns back and 1 row up, which is 0. Since the total weight of the second item is 3, so that's why we went 3 back and then 1 up, which is 0. Or we can just ignore the second item and put the first item, which is 1, which has a value of 1. And in here, since 4 plus 0 is 4, and the other item is 1, the maximum item that we can have is the second item, which has a value of 4. Therefore, we will be putting 4 here, which also goes with this one. Since this is a knapsack that has a total weight of 4, we can add the second item, which has a total weight of 3. So we will have a value of 4 here, plus 3 back and then 1 up, which is 1. We can add the first item as well, which will make a total weight of 4, which we can put inside the knapsack that has a total weight of 4. And then we either pick the 2 or just the 1, and we can see that the combination of the two items is way better in terms of value, which is 5, than the 1. Therefore, we will be putting here 5. And since this is the maximum that we can get, the 5 one, since that's the combination of the two items, we can get any more items in this row. Therefore, we're going to be putting 5s here as well. And in the third row, which is an item that has a total weight of 4, we can do the what we did the earlier row. And since this knapsack is 1, we can only put the item that has a total weight of 1 as well. And I believe we can put it in here as well, since this knapsack only has 1 value. And on the number 2, I believe we can put the 1s here as well, since we don't have any item that has a total weight of 2 or less than the first item, which has a value of 1. In here, we can add the third item, which has a value of 4. So I believe we can put the second item here as well. And then in the total knapsack of 4, we can add the third item, which has a total weight of 4. Therefore, we can add it with the value of 5. So this is the value 5 plus 4 columns down, 1, 2, 3, 4, and 1 up, which is 0. Or we will ignore this item and go for the item which is above it, which is the combination of the first and second item, which has the total number of 5 value. Therefore, we'll put 5 here. Therefore, we can either pick the first and second item or the third item, which is also a value of 5, and we can put 5 here as well. Then for the fifth column, the total weight of 5 knapsack, we can put the third item, which is a total number 4 here, which has a value of 5, plus 4 rows down, 1, 2, 3, 4, and then 1 up, which is 1, which is the value of the first item. Or we can ignore that and get the item before it, the value before it, which is 5. And since 5 plus 1 is 6, which is greater than 5, we can get the first and third item, which has a total weight of 5, which this knapsack can get, which has a bigger value than the previous one, which is 6. Then on the on the knapsack, which has a total weight of 6, we can get the third and first item as well, which is the third item, which has a value 5, plus 4 rows down, 4 columns down, 1, 2, 3, 4, 1 up, which is 1. That is, or we can ignore that item and go for the previous value, which is 5. And since 6 is greater than 5 again, we can put 6 here. And then for the total weight of knapsack 7, we can get the third item again, which has a total number of 5, plus 4 rows down, 1, 2, 3, 4, and then 1 up, which is 4, which is the total value of just the second item, which is 4, which has a weight of 3. Or we can just ignore it and get the previous value, which is 5. Since 5 plus 4 is greater than just 5, we can assume that the item combination of the second and third item is better for our knapsack. Therefore, we will put here 5 plus 4, which is 9. And in here, and the third knapsack again, and the last item, which is 5. Since we can't put anything else here in the knapsack, this has a total weight of 3. Then the second item, which has a value of 4, we will be putting 4 here. Then in number 4, since we can't put anything else other than either the third item or the combination of first and second item, which is 5, we'll just be putting 5 here. And in here, in the fifth column, which has a total weight of 5, we can put the last item, which is a weight of 5, and a value of 7, which is way better than the previous one. Again, value of 7, plus 5 columns down, 1, 2, 3, 4, 5, then 1 up, which is 0, or the previous item, which is 6. 7 is greater than 6, therefore we put 7 here, which is choosing the last item instead of the previous items. On the knapsack, which has a total weight of 6 as well, we can put the last item, which is a total number of 5, therefore putting 7, plus 5 columns down, 1, 2, 3, 4, 5, and then 1 up, which is 1, the value of the first item, or just the previous value, which is 6. 7 plus 1 is 8, which is greater than 6. We can put 8 here, which is the value of the first and last item, which has a total weight of 6, which this knapsack can take. And then on the 7th column, we can put the last item again, which is 5, which is a value of 7, plus 5 columns down, 1, 2, 3, 4, 5, 1 up, which is 1, or we can just get the item which is above it, which is 9. And in here, we can see that 7 plus 1 is 8, which is less than 9, which is the value of the combination of the second and the third item. Since 9 is greater, we will be putting 9 here. This completes the table. Okay, now what if someone asks what are the items that tells us that they have a value of 9, which is the maximum value that we can get in our knapsack. So we take a look at our matrix here, and since 9 is not coming from the left side, which is 8, which is the previous column, but it's going up, it's coming from the top part, which is also 9. Therefore, this is our anchor now, and it's telling us that this item is not inside the knapsack. And in here, since if we go up here, it's 5, and it's not going up, it's more on the left side. This is indicating us that since we can't get up, this item in this row must be inside the knapsack. Therefore, item which has a weight of 4 and a value of 5 is inside the knapsack. Now, since item that has a value of 5 and a weight of 4 is inside the knapsack, we go 4 steps back, 1, 2, 3, 4, and then 1 step up, and we're here now. Since weight 4, total weight of 7 minus 4 is 3. This is the only ones that we can focus on now. Since in here, it's telling us that the maximum value that we can get here is 4, and if we go up, it's not the same. It's not 4 as well. It's 1. It's telling us that this item here in this row is inside the knapsack as well. Therefore, item with a weight of 3 and the value of 4 is inside the knapsack as well. And in here, since its weight is 3, we will be going back 3 steps, 1, 2, 3, then one up, and once we hit the weight of 0, it's telling us that we're done, and we know the items now that's inside the knapsack.